Okay, this is the setup for using the signals with the timeline. Um, there's going to be only a few things that you really need to control to put together a show. So again, a show is put together by a series of scene sequences, and the sequences per object are stored in the timeline asset for that particular scene and are played by the playable director. So here we have the stage lighting, and the stage, you have a lighting scheme controller here with several different palettes to use. They can be added to. You can create more custom palettes. It won't take that long to integrate them in. You have your EFX wire controllers, which are these things that blink on and off on the animatronics bots. And then you have your signal receiver here. Basically, these are links that fire off the various methods that are contained in your lighting scheme controller, spotlight dynamics, and EL wires. So, and again down here, you can see in the playable director, here's your staged lighting timeline. Okay. So under there, you'll see all the things that we basically control, including the saucer LED strips. Then we have your virtual rigs. And your virtual rigs are basically your signal chain. The way this works is you have a master rig, which is basically controlled by the animator state machine here, which I've made into a gesturing engine, if you will, so that you can rapidly fill various scenes with gestures and moving animatronics, and it'll probably be appropriate for most of your use. And then you're going to want to use the custom animations, maybe mocap, suit integration, to drive specific points in it when you want to make specific points. Specific acting gestures, directions that the characters may take that are not handled by that. So you get things like navigate, gesture, narrating, dance, crouching, and various caricature walks, and a jump, and then basically idle, which is where the entry point is in. So each one of these, for instance, you got navigate. So we go in there, and there's actually a blend tree in here. So we'll use the Unity model so that we can see it, and we'll play this and show you that when this actually changed, when you change this number up here, you can see that there's various types of run backwards, run forwards, sneaking. You move this value at the top more, and he starts moving into walking. You turn the value up, and he's running, and then you stop, and he's going backwards. Now, of course, in the animatronics, they're not going to move. The root is going to stay in, but if you want to simulate like a mime of a person walking, then you got that. All right, so you go back to the base layer and say you got a gesture tree. Gesture trees work the same way. The character will start gesturing. It's good for if they have a lot of back talk and stuff that they're doing, a discussion with the audience. You can change it. Then he's got all different kinds of gestures, talking, various things like that. You can stop it in any place and he'll basically loop. And so you could have it where each one, if you go into the Animator Controller for each one of them, you can set, if you'll notice here, the gesturing can be set from here. So say you go 0.1, and it'll always do 0.1. It's not doing it over here. But you can see over there. If you look at each one of the animations gets lit up, shows you basically how much it's using, and they're blending between the animations. So we'll go back to base. We'll take another look at, say, the narrating, which is kind of like gesturing, but it's a little bit different in its character. So you can see that he's more emphatic, drawing things in the air, trying to explain things, conducting his conversation, if you will. This is how this goes. Look at that. And then, I'm telling you, that's the way it is, buddy. You better watch out. Oh my God, it was so big. I'm going to show you the greatest thing that ever happened. You know, it encompassed the entire world, da 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 da, that kind of stuff. You know, so you want him to dance? We got some dances that he can do. So get that moving. Do a little bit of twerk in there. A little bit of let's twist again like we did last summer. Uh-oh, look at it. I'm gonna out hip hop rap you. Look at that. Now I'm Captain Shuffle. You know, now we're back to let's twist again like we did last summer, etc., etc. So that's basically how that works. Then we got various caricature walks. We got the Shuffle Old Man routine. We got the stealthy sneak, look around. Now he's Mr. Keep on Trucking kind of dude. Now, oh my goodness, look at this. Ain't this just the greatest thing you ever seen? Holy cow, how did I get here? Oh, time to sneak again, etc., etc. So the idea behind these animator trees is that it's a basic gesturing engine for you to sketch out the background way that the characters are going to act. These are found, if you go under the rig controlled objects, I have them grouped here. So you would basically go into the master IK rig and you would drop signals along the timeline, which you do by doing a right click and do an add signal emitter. And that'll drop a signal on the timeline. Then you can look at it over here and you see that it says master rig, use caricature walk. So you go in and I've got them all grouped into sections here with the prefix for what they're controlling. So all the master rigs are going to have master rig in front of it. So you do that. You can do stuff like set the dance speed, cycle duration, choose whether it's going to dance, gesture, narrate, etc., etc. So you put a few of these on, and they'll change the way that the master IK rig uses the controller to drive its motion. So then the signal chain from here goes the master IK rig, and then the puppeteer rig has a IK robotic system. Each one of the servos is only rotatable on the Z-axis, and then because you can't do things like combine the shoulder all into one like you can with the rig, and you can't decompose the XYZ rotations because it just won't work properly. You have to kind of derive the rotations that the servos are going to need from an IK or an inverse kinematics. So what's done here in the master IK rig is that we put IK objects that this rig is trying to reach with its limbs and its head look and all that. And then as those servos are rotated, the rotations are read, and they're fed down into the animatronics output. The animatronics output picks up the servo rotations, and it'll create a packet by reading all the servos, organizing the bytes. It'll change the rotations, which are basically in radians, and then we have to convert that over into a 0 to 255 uh, series or an array so that we can create packets, and then the packets are sent out to the servos on the actual stage to drive the robots. And again, they're driven by the master IK rig, which is driven by animations and retargeting. And that's where you're going to control the final output to the servos is from the input that you're giving the master IK rig, and then the puppeteer rigs trying to follow it. Now up here, each one of the rigs has a spotlight that's associated with it. You know, spotlight 1, and these are DMX spotlights. So the DMX spotlights are basically controlled. You have a look at target, and if you'll notice that we have these proxy rig target. Move that ahead. Rig 3 proxy target. That's for the spotlight to point at. The reason for that is that most of the time you're going to want the spotlight to point at the bots. But there's going to be times, like such as in a marquee sweep or whatever, that you don't want it to point at the bots. So to avoid like high levels of programming and infinite if or switch conditionals, then we just have it point at this, and we use the lighting scheme controller to control how the lights are going to fire, and they continually follow these. So you can move these around to different positions, and the spotlight is going to follow it at runtime. Then the spotlight's rotations are read, as well as this color that it's currently at, and then that's going to be fed back, and byte packets are going to be created to be fed to the DMX controllers. So that's the way that works. Same thing with the LED strips that are going on the saucers. These have 3 different, well, they got the RGB and then intensity on and off kind of things, and you'll see that we've got the channel out, which channel that it's going to be going out on, and the color value that it's going to be at. So it'll read that out, and just to show you how this works, we've got a bunch of signals to control the lighting along the timeline, and then we've got 1 or 2 signals on each one of these. For instance, the rig 1, we're going to have them do a caricature walk, and in about 10 seconds we're going to have a master rig dance. And then on number 2, go to the master IK rig, and we'll have master rig gesture, and over here, master rig use caricature walk. Of course, you can drag these down and extend the timeline farther. And let's put it at here, let's say at 5 seconds, that he's going to do a different type of signal. So we'll add a signal emitter here, and then we'll figure out which signal we're going to use. And we'll say master rig, gesture. I think that's different than this, right? Yeah, okay. So we'll take that back, and we'll go up here and watch the stage lighting scheme controller. And this controls all of them. It's got signals for each one of them. So you got lighting scheme, blend colors, spectral palette. You can see that it's also controlling the EFX wires. More lighting schemes for the DMX. EFX random ripple for the EL wire. Blazing ball palette. Use default look at target. Use lighting scheme flashing. Change the cycling duration to 2 seconds. Unfortunately, whatever number you set in here, I think it should be different, where every time you use a signal, if you want to set a different signal duration here, for say the set cycle duration, you should be able to set 3 here and set 2 somewhere else. Now, to alleviate this, if you like the cycling of 2, but at some place you want to do 3, you would go down here into the timeline, into the signals, and you would basically go into the lighting scheme signals, and you would, create a new signal in there. Let's just do it here just to show you how it works. So you create a new signal, and we'll call it lighting scheme change cycle duration to 3. Make sure we get rid of that extra space in there. Check your spelling. Create the signal, and then you would go back to the stage lighting here, and you would add the signal. So you'd add a reaction here, choose the lighting scheme, and you'll see, since we've used all the other ones up here, there's no other lighting scheme, so there's the one. So you can always tell if your signal receivers are full, because when you go and add a reaction like that, you'll be able to see. It'll either have members that you can add to your signal receiver or not. So then we go into here, and since we're in the lighting scheme controller, and we want to change cycle duration. Cycle to set cycle duration, and we'll set the cycle duration to 3. And so that's how you would do it if you happen to want a different value for something and you're already happy with one. If you're not happy with the duration or whatever, you can change that duration, but it'll change it every other time. If you want to use another duration, as I said, go into the appropriate folder, subfolder of the signals folder, and create your signals there. So just to watch this go, I'll turn the sound up a bit here. We'll play this one time. See them all moving around. The timeline up above is scrubbing across the signals. As it does that, it changes the lighting scheme. These white targets out front are the look at targets. The reason for them being there is you may have a thing where you have an object on stage. At that point, you may want all 4 bots to look at it, so you would lock those targets to the object to look at instead of having them locked. Right now, they're currently locked to stay a few meters in front of the master IK rigs head and what they're looking at, and then the bot rigs are programmed so that their head always looks at that. Now, if we want to look at the master IK rigs, we can see those, but we have to use a trick to do that, and that trick is involving the shader. So we have a shader, and we're set it to fade and the alpha to 0. So it's called master IK body, and it's found under the hard assets. You go to that, you click on this, and you turn the alpha channel on, and you'll be able to see the IK box, master IK rigs. So you can see them move around if you need to. For the most part, they'll be off, so you can see the actual box. So that's the basic setup of a scene using signals and receivers. You're mostly looking to control the stage lighting. It already has a receiver on there. Then you got your rig controlled objects, which, you know, when you unfold each one of these, it's the first one in the hierarchy that you look at. The saucer rig is a little bit different from the other ones. It's not that hard to figure out. I'll do a short little tutorial on that to add to the suite of tutorials. So that's basically it. That's the use of signals and receivers along the timeline to create a scene. Again, you take a number of these scenes, you can put them together, pull the signals back and forth, signal emitters along the timeline so that they send it to the signal receiver, which is basically controlling the functionality of the object that it's sitting on. And in this case, the signal receiver is controlling the master IK rig. It has its various animation bools that it sets here, head look at target, and here's the thing where you lock the head look target to the rig head. That's those little white things that were bouncing around everywhere, and when they're checked, they say they lock to the IK rig head. If this is unchecked, you can place these anywhere, and the bot will always be looking at these objects, the animatronic bots.